February the 8th through the 12th, lesson 30. This is special lines in a triangle. We've been talking about mid-segments. So we're going to examine the relationships created by special lines in the triangle, namely what we call medians. Alright, so let's go ahead and look at this lesson. In triangle ABC at the right, D is the midpoint of segment AB. E is the midpoint of segment BC, and F is the midpoint of segment AC. Complete each statement below. DE, so if I draw DE, is parallel to what? Well, if you remember when we did our lesson on mid-segments, it said it would be parallel to the third side of the triangle. So DE would be parallel to AC and measures blank the length of blank. So we said that the mid-segment was parallel to the third side of the triangle, and it was also 1/2 the length of that third side. So it is 1/2 the length of AC. Okay? Alright, DF, so if I draw DF, DF would be parallel to BC and measures 1/2 the length of BC. And then if we draw EF, it would be parallel to BA and would be 1/2 the measure of BA. Alright, so that's all just review of what our last lesson was. In the previous two lessons, we proved that A, the mid-segment of a triangle, is parallel to the third side and 1/2 the length of the third side, and B, diagonals of a parallelogram bisect each other. We use both of these facts to prove the following assertion. All medians of a triangle are concurrent. That is, the three medians of a triangle, the segments connecting each vertex to the midpoint of the opposite side, meet at a single point. This point of concurrency is called the centroid of the center of gravity of a triangle. The proof will also show a length relationship for each median. The length from the vertex to the centroid is twice the length from the centroid to the midpoint of the side. Okay, so let's kind of talk about, I'm just going to use this figure here. So what this is telling me is it's telling me that all medians will meet at one point. A median takes a midpoint and connects it to the opposite vertex. So like I would draw a line from B to F, and from A to E, and from C to D. And when you do that, you're going to see that they all meet at one particular point. And it says that's called our centroid, or the center of gravity. It will also show a relationship of the median, the length from the vertex to the centroid, so from A to whatever the middle point is twice the length from the centroid to the midpoint. Okay? So that's what we're going to work on proving. Okay. So let's go ahead and look at this. So it says, provide a valid reason for each step in the proof below. So they have now gone to given us some of our proof here. We are given triangle ABC with D, E, and F being the midpoints. They want us to prove the three medians of ABC meet at a single point. So it says draw AE and DC. Okay, label their intersection as point G. So they've already done that for us. They drew AE and DC, and there's point G. Construct and label the midpoint of AG as point H. and the midpoint of GC is point J. So they've done that for us also. All right, so they want to know, how do I know that DE is parallel to AC? Well, DE is the midsegment of triangle ABC. It is a midsegment. And remember, midsegments are parallel to the third side. So how do I know that HJ is parallel to AC? Well, it is a midsegment of triangle AGC. All right? So we can say that HJ is a midsegment of triangle AGC. And I know that because remember it says these were midpoints. Alright, why do I know that DE? So DE is parallel to HJ. Well, if two segments are parallel to the same segment, then they're parallel to each other. Okay? And I abbreviated parallel. So since I know that DE and HJ are both parallel to AC, then we know that they are parallel also. Alright? How do I know that DE is 1/2 of AC and that HJ is 1/2 of AC? Well, what's the definition of a midsegment? Midsegments are 1/2 the length of the third side. DEJH is a parallelogram. Well, we've already proven one side to be parallel, so one pair of sides of a quadrilateral are parallel, and we've also proven them to be equal. So since they're parallel and equal in length, then I know that I have a parallelogram. Alright, so how do I know that HG is equal to EG and that JG is equal to DG? Well, if I have a parallelogram, then what do I know about the diagonals? They bisect each other. And if they bisect each other, they divide each other into 2 equal parts. Alright, why do I know that AH is equal to HG and CJ is equal to JG? Well, if you remember, it told us that H was a midpoint of AG and that J was the midpoint of GC. So that is the definition of a midpoint. Alright, AH is equal to HG is equal to GE, and CJ is equal to JG is equal to GD. That is substitution. Because we have proven all of these to be equal. Alright? So AG is equal to 2GE and CG is equal to 2GD. That is our segment addition postulate. We can compare, or we can complete steps 1 through 11 to include the median from B. The third median, BF, passes through point G, which divides into two segments such that the longer part is twice the shorter. And the intersection point of the median divides each median into two parts with lengths in the ratio of 2 to 1. Therefore, all medians are concurrent at that point. So, they want to know the three medians of a triangle are concurrent at what point? Where are they? They're concurrent at the centroid. Or the center of gravity. This point of concurrency divides the length of each median into a ratio of 2 to 1. The length from the vertex to the centroid is blank the length of the centroid to the midpoint on the sides. It is twice the length. Okay? So now that we have done this proof, we're going to use this information. In the figure to the right, DF equals 4. BF equals 16. And AG equals 30. Find the following measures. FC. Okay. So, if you remember, it says that if I have a centroid here, alright, the length from the vertex to the centroid is twice the length from the centroid to the midpoint of the side. Alright, so FC, I'm going to find FC. So that means that if this is 4, then this is going to be twice that length, so this would be 8. Alright, the length of the vertex to the centroid is twice the length from the centroid to the midpoint. So whatever this is, this other part's going to be twice that long. Alright, DC. So DC, since I know that this is 8 and the other part is 4, 8 plus 4 is 12. AF. Alright, now it told us that AG, the total is 30. Alright, so I've got to think about this for a second. I've got to break that up into two parts. One of them is 2x, and one of them is x. That's going to be 30. Alright, so 3x is equal to 30, means x is equal to 10. Alright? So that means that AF, that's the point from the vertex to the centroid, it's twice as long as this one. So if this is x, that means it's 10. This one has to be 20. Alright, BE. Well, let's look. BF is 16. That means it is twice as long as this one. Alright, so FE has to be 8, which we can come down here and do that one. So 16 plus 8 is 24. And then FG. So it tells us that AG, so we found AF was 20, FG is 10. We've already done that one. Okay? Alright. triangle ABC is reflected over segment AB to create triangle ABD. Points P, E, and F are midpoints of segment AB, segment BD, and segment BC respectively. If AH is equal to AG, prove that PH is equal to GP. Okay, so let's go ahead and look at our given information. Our given information is that it is reflected over AB to create triangle ABD. I can write that down if you want to. You don't necessarily have to. Alright, so we know that AH is equal to AG, and they want us to prove that PH is equal to GP. So this is what I'm trying to prove right here. Alright, so what do I know? Let's see here. Well, what do I know about AF and AE? I know that AF is equal to AE because in rigid motions, segments are preserved. Alright, that was one of the things we first learned about when we do reflections, rotations. We figure out that our segments don't change. Okay, so in that case, then what do I know about angle FAB? What do I know about angle FAB and angle EAB? I know that they are also equal because angles are preserved. Alright, when I'm doing rigid motions, my angles are preserved. Alright, so here we go. Alright, and then I'm going to list this because this was given, that AH was equal to AG. And I already have that marked. Alright, now look, what do I know about AP? AP is equal to AP by reflexive property. Alright, so now let's look at this. Can I prove those triangles congruent? Alright, so triangle APH is congruent to triangle APG by side angle side. And since those triangles are congruent, then I can prove that PH is equal to GP because of CPCTC. Alright, there you go guys. Have a great day.